Welcome back. Now it's time for another session, and now I'm with Martin Ullrich, who works as a senior consultant at TO Every, and Martin will tell us about optimizing the cloud in his presentation, lightningspeed.net apps. As always, you can post question to Martin on a chat, and I don't waste your time. So Martin, make a show, please.
Hi, thanks so much for having me. So, my name is Martin. You can find me also on Twitter, also on GitHub. I do have a Stack Overflow presence as well. A lot of the stuff that I cover, I usually also write on Stack Overflow. So if you have questions, also maybe send them my way. So today I want to go through a bit of what kind of optimizations we can do in .NET. I want to show you some code and do that, and also give you some practical recommendations that you can use. During this presentation, there will be one thing you can probably immediately do to all of your applications. I will tell you that in a bit. So what I commonly run across is making decisions. Do I scale my cloud infrastructure up to get more performance if I run into bottlenecks, or do I spend time improving the applications? So it's usually a cost analysis, like does it cost me more to actually work on hard problems on improvement, or do I just pay more money to Azure? But also in serverless applications, I really get charged for the CPU time that I use. So when I have higher and higher throughput, maybe making the application more efficient results in a lower Azure bill. And also, if I have cold starts for serverless applications, maybe also some startups that garbage collected languages like C# have are a bit, or JITted languages, maybe are something that we can try to optimize away. So I personally like to use Kubernetes. There are a few things that help me there. First of all, container size really matters, especially when I deploy to other regions, or even, for example, using Azure Arc to on-premise clusters as well. So getting containers down to maybe 50 megabytes instead of having 100, 200 megabytes is a really good thing to do in that scenarios. Also, if I have like high density deployments, for example, if I run 20 to 30 pods on a single node, I do want to set memory requests and also limits. But then if I set limits, can I run efficiently on like a fourth of a CPU? Does it improve throughput? Does it, or do I need more performance for jitting during startup? So that can be kind of an issue. For example, if I schedule jobs through cron jobs, maybe the job runs for a minute and a half, and maybe 90% of that was just the startup time for .NET to JIT all the methods and for everything to start up, because maybe I don't want this JIT time to degrade the performance of other things running on the same CPU. And speaking of limits, there are usually a couple of different approaches to limits. If you don't set any limits, some people recommend that. However, you can kill your node by taking resources away from other processes. If you set the limits too high, you compete with other processes. And if you set very low limits, what I usually do, you get kind of predictable behavior, but the startup time will just be horrible. Maybe you can deal with that, maybe not. However, there are different things for optimizing. First of all, I don't want to go into detail about everything you can do. If your application is written poorly, I can't do anything about it. So garbage in, garbage out. Runtime cannot fix your code. So maybe use performance profiles, use tool to analyze what's going on in your software if you want to optimize for throughput. Yeah, so benchmarking really helps here. Also, have a look at new APIs. There are new APIs in every .NET release, and every performance-related documentation will guide you through them. So, for example, hardware acceleration using vector classes, using the new span APIs, or value task instead of task for things that are mostly non-asynchronous code paths like caching. But what other things can you do? So first of all, try to stay on the latest .NET. we will benefit from all the work that the runtime teams puts into optimizing the core runtime. Also, you can use code generation features in the latest versions of .NET if you have regexes, if you use JSON. Even for logging, there are source generators that generate C# code into a project so that the runtime doesn't have to do a lot of like dynamic lookups, reflections, or just-in-time compilation. And there are also some great runtime features to use. So tiered compilation was introduced in .NET 3, and dynamic profile guided optimization, I'll cover both of these in a bit, is opt-in. It may be on by default in .NET 8. However, talking about something that's in preview is a bit messy, so that might change. There, of course, are other runtime settings. So, for example, you can set thread behaviors, you can set garbage collector behaviors. If you know what you're doing, those are great knobs to twist. However, I usually don't. So I try to make sure that my application behaves correctly, and the runtime team is constantly optimizing those components for the various places that they support running. For example, behaving good in containers with low limits. And since I mentioned jitting, we can pre-jit some code in .NET. So for example, in .NET Framework, we also had that feature. We installed a .NET application, and then we could use Ngen, the native image generator, to reduce the startup time of the application by pre-jitting some of the machine code that would otherwise be generated on application start. This is using the ready-to-run format. This is actually tied to a specific runtime. So your DLL file will increase in size and also already contain a pre-compiled version for a specific runtime. If you copy it to some other machine, it will have to JIT again, but it should work. And the way to use this in .NET is you can either in a project file or as a command line parameter set publish ready to run. And this will generate a code if you're publishing for a specific runtime. And if you're publishing a bunch of application or a bunch of DLLs together, for example, in self-contained applications, you can also set publish ready to run composite to true, which will also include some optimizations that would be cross-module. So for example, if one DLL file calls a method in another DLL file, when this is true, it might get inlined, which of course it could not do if you would distribute your binaries independently of another. So, however, there is a significant compile time trade-off that got a bit reduced over the last releases. For an application that I'm working on, it's about 2 minutes that it takes for everything to be pre-jitted during building in Azure DevOps. So, tiered compilation, also a feature that's now on by default, but I needed it to explain something else in a bit. So tiered compilation works that the compiler tries to generate some machine code as fast as possible. This will be unoptimized code because optimization takes time to process. So it like quickly generates the most basic implementation, most basic machine code that implements the .NET method. Then if it detects that, for example, a method is called a certain number of times, or if a class is used a certain number of times, it would optimize the code for hot path. So it would run the JIT again with some more optimizations turned on, and then replace the machine code in place to be more efficient. So if I have tier 0, maybe all the startup code that's only run once is generated quickly and runs, and then more effort is put into the things that run constantly and all the time. This is on by default in .NET 3. There are ways to turn it off and on. However, I don't think you will be needing those a lot. But building on top of that, there's also profile-guided optimization. So I mentioned hot paths are detected and then optimized. The way this works is that JIT introduces some call countings into the tier 0 code. But what we can also do is use existing knowledge about the behavior of app to improve it. So somehow we need to measure how the code is executed in production-like scenarios. For example, which methods get called a lot, but also what implementation types do I use when I pass interfaces? And especially in .NET, where we like to create a lot of interfaces, but then usually only have one implementation, maybe two, that can help. And once we know all these things, we can optimize the generated code. This can be done, for example, statically. It's been available for C++ applications forever. For .NET application or .NET Framework application, there were some internal tools used by Microsoft. Now in .NET 6, 7, 8, these are public tools now. But you can collect traces while running the application, generate PGO information from those traces, and recompile the application with that information. Yeah, that means optimized code will be ready for the first request. Startup time will improve, likely. And it's very good to combine with other ahead of time compilation techniques, such as I mentioned, publish ready to run, which will pre-generate this optimized JIT code. There are some trade-offs. For example, production-like traces are very hard to obtain. Like you can run something in debug mode, you can run an integration test, but what really happens in production, it's hard to know. So what you also need to do is once you publish and you collect the traces and you go back and you want to publish again, you need to keep the trace in sync with the actual application. So that can be kind of hard. The solution for this would be dynamic PGO. Dynamic means it does the optimization while it's running, and it makes use of this tiered compilation feature. So it introduces some compiler hooks or some hooks into the generated tier 0 code to do all the measurements. And then when it rejects the method for a tier 1, it will use this profiled information. Yeah, that means the code might not be so fast to begin with on the first run. There is a very small overhead. However, the .NET team is working on reducing that a lot. And of course, it means you already have production data if you run in production, so you don't have to go back and forth with rebuilding and everything. And it's easy to just enable. So it's opt-in in .NET 6 and 7. It will likely be on by default for some workloads in .NET 8. I guess once we get closer to release candidate, we can have more confident descriptions of that. So the one thing that you can probably do in every application that you're working on right now is enable tiered PGO. Just setting that one property to true will likely yield better results for the throughput of your application. Let me show you a bit of that. So I have an application here. It does a very stupid thing. It has an interface factory that creates things, also an interface iThing. You can give the thing a treat, ask it if it's feeling happy, and then there are just single implementations for both of these interfaces. And then there is a loop, actually nested loops, that run this a couple of times and then tell us how long that takes. So if I just type .NET run, it will run this. However, never do performance analysis in debug mode, so we want to run in release mode. And you can see it's around 350 milliseconds. So if I then turn a few things off in here, if I then make sure I turn on tiered compilation, it doesn't change much, but since I'm using interfaces a lot with a single implementation, maybe this can help. And it does. We still have a longer first run, but the other runs are have a very high reduction in the time that they take to run. The way this works is that it looks at what's executing, and then, for example, here in, let's do, it would create an if thing is thing, it would call the method directly. because otherwise it will have to do the full virtual method lookup, virtual dispatch lookup, looking at the interface, looking at the concrete type, trying to figure out which method to call. However, since we kind of know what's in there, it can help us generate more efficient code to do that. But this first iteration is still a bit fast. There are things we can do about that. So I mentioned we also have tools for static PGO. So if I try to collect a performance trace now, I have a quick cheat sheet of how to do that. Setting a few environment variables, mostly setting a few parameters, making sure that we don't use pre-jitted code, enable the performance counters, but then enable event pipes to just pipe out the events that are generated. Now, if I call that method again with these variables, I will get a trace, trace.net trace. I will copy that. And then I can use a tool called .NET PGO, which helps me working with PGO data. And I can create an MIBC file. Those contain the informations that are used by the compiler. Okay, I have this MIBC file. I can also create a dump of what's in there. So there's like a lot of block counts. And it collects, for example, histograms of what parameters get passed into certain methods. For example, here it says, okay, this only the thing class is passed into that method or that particular place in the IL code. And then if I want to publish the application for a specific runtime, I can do the pre-compilation. .NET publish, release, in this case for Windows. Publish ready to run. And you can see it starts out quite fast, so we don't have this like first run trade-off. However, it becomes slow again. The reason is that the tier 0, that this generated code does not have the same call counts and the same performance counts. So when it tries to reach a hot path, it doesn't work. A way to fix that is to include the PGO data into the application. We can use that by adding some extra arguments that are passed to the pre-compilation tool to embed this data that I pass into it using the MIBC file. If I republish now, we should be fast every single time from the first call to the last call. So that's possible with PGO. What we can also do to reduce the size of application is trimming. It's usually used to reduce the size of self-contained apps. So you can remove unused assemblies and code paths. So you can it's based on the root assemblies. It looks at certain assemblies and then does tree shaking. It shakes the tree and everything that's not fixed to the root falls off. And there are certain trim modes. Usually all assemblies are trimmed by default. There's also a partial trim mode where only assemblies that opt into trimming will be considered. But I really suggest to try to trim as aggressively as possible. There are some limitations, so dynamic code can be problematic if you access things via reflection. That type or even just the method might not be there. It doesn't work with COM. However, the new COM wrappers might work. And WinForms does not yet work. And WPF applications, well, they use reflection and runtime code inspection very heavily. So likely a lot of the code you write would be trimmed away and then not be available to use in WPF. What you can do is use, for example, system textuation source generators for serialization that relies on like looking at what types you used, what properties they have. Dynamic assembly loading can be a bit of a problem since your assembly might just be gone. And of course, there's some attributes you can annotate your code with to tell the trimmer what it's supposed to do. Like, do I dynamically access some members if I just pass a type somewhere? Do I have some dependencies? Or I can mark a function to say, okay, if you're trimming, this function will not work to produce the corrected diagnostics during build. If you're a library author, first thing you can do is set enable trim analyzer to true to see all of these instances where you need to do some work to fix your problems. And you can, if you do that, you can mark your library as trimmable. However, in .NET 7, the full trimming is not a default. So that's the way forward. I'll give you a very quick demo of that. So I have a sample application that uses some plugins of another library. And what it does, it calls find all plugin names and in a plugin utility, and this uses basically reflection to look at all the implementations of a specific interface and instantiate them and return the name. And if I publish that for Windows, self-contained, with published trimmed, so perfectly already get some warnings because now it says, hey, you're using some code that's not really useful for trim. You can also see before I enabled this, we had like 72 megabytes in here. Now it's just 17 megabytes. However, if I run the application now, it will not find any plugins because those are gone. I can do something here to help. I can annotate my code correctly. So yeah, if you use this type, then I will use all members of the type. I can also tell this find method that it has specific dependencies. So for example, plugin B is used and plugin A. There's also other ways to do it. So I could use a static constructor and have a type property in there where I also say, hey, if you see a type being assigned here, so plugin C, please keep all members of that type. Of course, this requires statically listing all the dependencies, so maybe a plugin system would not make sense here. But now that should work, and we should see all the plugins. So, however, there's one more thing, and that's a theme that has seen a lot of investment over the last years, is native ahead of time compilation. What it does, it fully ahead of time compiles the entire application. You will then run on a specialized runtime where there is no JIT available. So there is no dynamic code generation. There's no rejitting of some code paths. Just the application is compiled the way it is and then shipped and run. And you only basically have garbage collection and some limited basically read-only reflection abilities. This also results in the smallest binary size. It is supported for console apps in .NET 7. Libraries may or may not work. ASP.NET Core is explicitly not supported in .NET 7, but that's about to change. And the prerequisite is that your application and all the libraries it uses need to be trimmable. So it creates basically what we would call a self-contained application, and then trim everything away, and then do the ahead of time compilation. This, of course, requires C, C++, and linker tool chains for producing the final output. Again, there are some limitations, so no runtime code generation. Reflection emit will just not work. Cannot dynamically load assemblies, because if you load a JIT, a file that has to be JITted, it can't. You can't use like the C++ CLI integrations of like Windows-specific applications. Again, no COM, and it requires trimming. Also, some of the same limits to single file deployments exist, so some methods might throw an exception. But in .NET 8, they now announced that they want to support web APIs. So simple, minimal web API projects, they should work. Maybe they're also looking into supporting controllers or MVC. But they might do it, they might not. However, what they are not focusing on is Razor, Blazor, and also the Entity Framework Core. I guess they're not very optimistic, but I think there's some work happening there. So maybe over the next .NET releases, we will see more and more workloads being supported. They did make some performance comparisons. So you can see the application size is very much reduced. I think they're now down to like 7 or 8 megabytes. Memory usage is a lot lower, and the startup time is just fast. Let's have a look at that in action. So I prepared a small web API demo here. This is basically the new minimal API sample. It just generates some sample to-dos, returns them. Yep, 400, but at least it's running. Now what I can do is call .NET publish in release configuration for the runtime Windows 64-bit. Publish AOT equals true is the magic command. And now it says generating native code. Okay, release, publish. Now I only have 2 files here. And the file is 9.5 megabytes. The startup is fast. However, it will have exceptions. And those are because the application is trimmed. It loses a lot of the type information of the things that are used. For example, to do is used. But it says, the JSON type info is just not there. And it doesn't really know what to do. So we can help with that. So we can use the system text JSON serializer code generator, for which I can create JSON serializer context subclasses. They have to be partial, annotate them with the types that I want to be using in my application. And then when I set up my application, I can configure the HTTP JSON options and tell it, hey, if you're serializing JSON, also make sure you have the information of that context. So let me build again. We can also have a look at the code that will be generated behind the scenes, I guess. So here it generates like the readers and writer methods. It has the type information of everything that's used. Let's see. So for example, it generates getter setter methods. So everything of the to-do class and all its dependencies is referenced in the C# code. So it should now no longer be trimmed away. I might have let that running for a while. And now, looks like it still didn't work. I'll give it one more try. Again, this is a .NET 8 preview version. And you will see these templates, but also the guidance how to use it, improve over time until the .NET 8 release. So let's try it one more time. If it doesn't work, it just doesn't work. It doesn't. But you get the gist of being able to reduce the startup time, the application size, and also the need for jitting. So that when I run my application in very low limits, they will be faster. I do have one summary slide for you. Those are my recommendations. First of all, always publish in release mode. I think that's even now the default in .NET Publish, or it will be at least in .NET 8. Try to enable tiered PGO, and then for faster startup, use ready to run. And if you want to optimize for size, maybe create a self-contained application, trim everything away that's not needed, and use ready to run and ready to run composite to pre-optimize it for the runtimes that you're targeting. So that, for example, instead of the full container base image that comes with the .NET runtime, you can maybe use an image that only has the runtime dependencies, and then use already small application on top of that. So with this, I would like to say thank you for attending. And I'm not sure, are there any questions?
Okay, thank you very much, Martin, for the presentation. And I look on our chat if we have any question. Our chat is empty, so there isn't any question to you. So thank you very much once again for your presentation. And don't forget to rate this presentation using stars under the video player, because your feedback is very important for us. So thank you very much for participation, and see you on next slot.